today's lecture, we'll look at cloud infrastructure and virtualization. Virtualization is the core concept of cloud computing, which actually makes cloud computing possible. So we've already seen overview of cloud computing, wherein we understood what are the resources. We saw that servers are housed in data centers, which all are and these all are data. These all servers are interconnected by the network, which is called intra data center network, and all the data centers are also connected by networks, which is called as inter data center network, and user will access services and these applications which are stored in the servers through the network. Then we saw five essential characteristics or defining attributes of cloud computing. We also understood what the four deployment models, which is public, private, community, and hybrid cloud. And then we went on to see three delivery models, which is software as a service, platform as a service, and infrastructure as a service. So basically, we have, if you see, we have five essential characteristics, four deployment models, and three delivery models. Today, we look at the fifth component, and we'll study virtualization in detail. So let us look at the infrastructure. So infrastructure, there are three terms which I want to introduce here. First is distributed infrastructure. So it says that servers or data centers need not be located in the same physical location as the users, and the service can be acquired from anywhere. Now this is very important. The servers which are in the data centers or from where the users are accessing the service over the network, they need not be physically in the same place as where the users are. They can be anywhere in the world, and the users can access the services from them over the network. Next is resource virtualization. So resource virtualization, so it is a very important, this in virtualized environment is very important requirement for cloud computing. And virtualization does not expose the location or mechanism of the underlying hardware to the virtual machines which are running on top of a single physical hardware. We'll look into more in detail in virtualization today in this lecture. So basically, if we see what it does is there is a layer of indirection which is created on top of hardware. So what does this layer of indirection do? It understands the hardware completely, and all the virtual machines which are running on top of this hardware, they interact with hardware through this layer of indirection. Next, let us see what is autonomous systems. So they are self-managed systems that can work independently with high-level guidance from humans. So in autonomous system, each one of these system can hold on its own, can work independently without human intervention. They can also work along with other systems in a distributed environment. This is the fifth component which was a part of overview of cloud computing. Now we'll start with virtualization in more detail. And so first let us see that from what was the need of virtualization or where it came from. So let us see this. So this is the layered architecture of any system. So we have physical hardware. On the top of physical hardware, there is an operating system. And on top of operating system, there are many applications which are running. So this operating system is nothing but a software which runs on this particular hardware. And it is an interface of all these applications to this hardware. Now, in case there is a requirement to run, there are multiple applications, and these multiple applications require different operating systems. For example, let us say that I have there is a requirement of two different operating systems. One is the Linux and one is Windows, and I want to run them on the same physical hardware. That is because I have these different applications. Let us say these two will run on Windows operating system, and these two require Linux operating system to work on. Then what happens is I need a layered architecture which is something like this. But this is not possible. Let us understand why this is not possible. Multiple operating systems on the same physical hardware is not possible because operating system is a software which is written for a particular instruction set architecture. ISA. ISA, what does ISA do? ISA abstracts a specific hardware. So there is a specific ISA for a specific hardware, and there is a specific operating system for a specific ISA. So operating system, ISA and physical hardware are closely tied together. Therefore, it is not possible to have two operating systems on one physical hardware. So this is called as multiple OS hardware problem. So let us see, operating system caters to a specific hardware which is expressed in terms of instruction set architecture. So what does ISA do? It defines the instruction set for the processor, registers, memory and interrupt management. So specific OSA is written for a specific ISA which in turn abstracts a specific hardware. Right. So further the applications are written for a specific OSA. So if you see that the applications will run on a specific operating system is written for a specific ISA. ISA abstracts a particular hardware. So they're closely tied together. Therefore, running multiple OS on the same hardware simultaneously is not possible. So you cannot run two hardwares simultaneously on a particular hardware. But now the question is, what about dual boot? We have systems in which there are two operating systems, but in that case, both the operating systems, they do not run on the hardware simultaneously. So what is done is storage is partitioned for each software. There is a separate storage for operating system 1, and there is a separate OS storage for operating system 2. So one OS will use the ISA, that is the registers and the memory, in a certain way, and simultaneously, and at the same time the other hard operating system will not be able to use it. So running multiple operating system simultaneously on a particular hardware was not possible. So what made that possible was virtualization. So we have a physical hardware and then we have operating system. Now above operating system, there is what is introduced is called as layer of indirection. So this is virtual machine manager. It is also popularly called as hypervisor. We'll look this in a later part of the lecture, that what is hypervisor. Now on top of hypervisor, many virtual machines can run. Now all these virtual machines are independent of each other. They are isolated. They can run their own operating system and have their own applications. So if you see, these are called as virtual machines. All these virtual machines, though they are running independently and may serve different users, but they are sharing the same physical hardware. So virtual machines can have different operating systems. Virtual machines are one instance of this trend, that is virtualization. So with a virtual machine, guest operating system and applications will run in an environment that appears and behaves towards them as native environment. Native environment means local environment, local hardware. that behaves towards them as native hardware would do, but also protects, manages, and limits them. So this virtual machine is completely independent and isolated from this virtual machine. At least that is what is required. So when a cloud provider has a server and he wants to cater to the demands of multiple users who are on that particular single server, then what is required is to create different virtual machines. Each of these virtual machine will be serving a particular user. But then the requirement is that these virtual machines should be able to operate independently. They should be secured. That is, this virtual machine cannot, they cannot have access to the data of the other virtual machine. So, and they should, so that means they should be completely isolated. So let's see this. So virtual machine implementation involves several components. At the base is the host. What is the host? The underlying hardware system that runs the virtual machine. The virtual machine manager, which is also known as hypervisor, creates and runs virtual machine by providing an interface that is identical to that of the host. Each guest process, that is operating system, is provided with a virtual copy of the host. So what will the hypervisor do? It will give a share of storage, a share of physical hardware, that is the input output ports, whatever is the requirement as per the demand of the user to that particular virtual machine. So it will allocate some of the hardware resources to a particular virtual machine. So this is done by this is taken care by a hypervisor. So a single physical machine can thus run multiple operating systems concurrently, each in its own virtual machine. So that means now it can run multiple operating systems simultaneously, but these operating systems run in their own virtual machines, which are completely isolated and independent. So let us see what is a little bit history of virtualization. So virtualization, we understand now, is a technology which is a fundamental component of cloud computing. So basically it's a very broad concept which refers to creation of virtual version of hardware or a software environment, storage, or a network. So this was first introduced by IBM on mainframe computers because they wanted to run multiple operating systems on their mainframes. So what happened was IBM VM370, it divided mainframe into multiple virtual machines, and each one of them was running their own operating system. So, but the major difficulty with the virtual machine approach was the disk system. Now, suppose a physical machine has four disks, but they want to let's say support 10 virtual machines. Then it could not, it cannot allocate one disk to one virtual machine. So then the solution was mini disk, which was a virtual disk allocated to each virtual machine. So the mini disk is actually identical to the system's hard disk in every respect excepting the size. So the system implements each mini disk by allocating as many tracks on the physical disk as the mini disk requires. Let us see the formal definition of virtualization. So virtualization is to abstract the hardware of a single computer, that is the CPU, memory, disk drives, network interface card, and so forth, into several execution environments, thereby creating the illusion that each separate environment is running on its own private computer. This is the concept of virtualization. In fact, when IBM came up with this concept of virtualization, it actually did not become popular immediately. It remained with IBM for a number of years. But then what happened was that by late 1990s, Intel 8086 CPU, they became very powerful. They became fast, rich in features, and then technologies like VMware and Zen were created, which allowed guest operating system to run on 8086 systems. So let us see some features of virtualization. So first is increased security. Um, Virtualization of the execution environment allows increased security. Now, security is also a threat in virtualization, and we'll look at that aspect of virtualization in later lectures. So there are two things. It provides security to the users, but then it is also a threat to the users because there are various virtual machines and each of them is accessing the same hardware. So it might be possible that one of the users through a particular virtual machine might get access to the data of another user who is on the same physical hardware but a different virtual machine. We'll look at that aspect a little later. So let us see the increased security feature of virtualization. So implementing virtual machines on a physical hardware provides the feature of increased security. And this is because these virtual machines which are implemented, firstly, they are completely isolated and independent from the other virtual machines which are running on the same physical hardware. And then the operations which are of a particular virtual machine are contained within them. If there are certain operations that need to be performed um, against the virtual machine, then what happens is they go via this hypervisor or virtual machine manager. So let us go back to the diagram. Okay, so let us see here. So this virtual machine, these virtual machines are completely independent. If they need to execute some instruction which has to be done on the physical hardware, then we go through this virtual machine manager. So this virtual machine manager can control and filter the activity of the guest which is running in the virtual machine. So this helps the feature of increased security. So let us go through these points. The ability to control the execution of a guest in a completely transparent manner, delivering a secure, controlled execution environment. That is creation of virtual machine. That is, each virtual machine is a controlled execution environment. And who controls them? Hypervisor controls them. We'll see in later in lecture that hypervisor can freeze the virtual machine, stop it, start, depending on whatever is the requirement. So hypervisor has a complete control of the execution environment, which is the virtual machine. Now the virtual machine represents an emulated environment in which the guest is executed. Okay, so let us look into this. So what is emulation? Emulation allows an application which is written for a particular hardware to run on a completely different hardware or an environment. So this is what emulation does. So for example, the operating system which is on top of the hardware is Windows, but then we can have virtual machines running on that particular host which are supporting different operating systems like Linux, right? So this is done through emulation. So that is why they say virtual machine represents an emulated environment. And then, so all the next is all the operations of the guests are generally performed against the virtual machine, which then translates and applies them to host. Then the level of indirection allows the virtual machine monitor to control and filter the activity of the guest, thus preventing harmful operations from being performed. So also an important thing is, since these machines are isolated, sensitive information contained in the host can be hidden without any need to install complex security policies. So increased security is a requirement when dealing with untrusted codes. So let us try to understand this. What are these untrusted codes? For example, if certain code, for example, an applet is downloaded from the internet. So what is an applet? Applet is application, a small application which is written in Java, and these applets are integrable. So if any such applet, Java applet is downloaded from the internet, if you run it on your own system, then it might be potentially harmful for the system. So instead of running on the system, where are they run? They are run on a Java virtual machine. Moreover, these virtual machines are sandboxed. So let us understand what sandboxing is. Sandbox refers to an isolated execution environment where potentially harmful instructions can be filtered and blocked before being translated and executed into a real execution environment. Right? So before putting those instructions on a real execution environment, they are executed in a sandboxed Java virtual machine, thus providing them with limited access to the host operating system resources, right? So this also is a very important feature, which very important area in which virtualization helped. Next feature of virtualization is sharing. Uh, this is pretty obvious. Virtualization allowed creation of separate computing environments within the host. So these all these multiple virtual machines, they are sharing the same physical hardware. If this was not possible, that is creation of virtual machine through virtualization wouldn't have been done, then the physical hardware, which is a huge infrastructure, could not have been completely utilized by a single user. And this would have led to underutilization of the resources. So sharing makes it possible to fully exploit the capabilities of the underlying hardware, which would have otherwise been underutilized. Further, reducing the number of active servers in data center uh, leads to reduction in power consumption. Okay, so this point needs little explanation. Let us see. So what do we have in data centers? We have multiple servers, tens and thousands of servers which are running. Now, each of these server consumes power, right? Because in fact, that is one of the major expenditure in cloud computing. That is the powering of data center, cooling them. So it is very costly. So what happens is that if you have multiple virtual machines which are running on a particular server, so if on one server, let's say you have 10 virtual machines which are running, on another server you have let's say only two virtual machines running, then what can be done is that these two virtual machines can be shifted to the server which is already running 10 virtual machines, and that server can be switched off, or it's called as put to sleep, so that power saving is there, is power saving is achieved. So this could only be done because of sharing. So multiple virtual machines can run on a particular physical hardware. So it indirectly also helps to reduce the number of active servers in the data center. So servers which are do not which are very less loaded, their load can be shifted to another data center which still has capacity to support those virtual machines, and then one of the and that server can be put to sleep, so that this leads to reduction in power consumption, or it leads to saving in energy. Third, third feature of virtualization, it is aggregation. So aggregation is a process which is opposite to that of sharing. So not only it is possible to share the physical resources among various users, but virtualization also allows aggregation. So that is what can a group of separate hosts, they can be tied together and represented to the guest as a single virtual host, right? So And for example, cluster management software harnesses the physical resources of a homogeneous group of machines and represents them as a single resource. So this can also be done. So what was sharing? Sharing was the physical infrastructure was so large that could not be consumed completely by a single user. So multiple users share that particular hardware or that particular resource. On the other hand, it might be possible the demand of the user is so high that a single infrastructure cannot fulfill that demand. So what can be done is many such infrastructure can be aggregated, and they can be presented to the user as a single resource. Emulation. So we understand what emulation is. It is that an application which is written for a particular hardware can run on a different hardware or a different environment. So emulation is one of the features of cloud computing. Now, let's say we have a software, old software, which cannot be run on, the current system. Then what can be done is a virtual machine can be created, which emulates the environment in which that old software can be run, and then it can run on the current hardware settings. So let's see, guest programs are executed within an environment that is controlled by virtualization layer, which is ultimately a program. So what does emulation it allows? It allows for controlling and tuning of the environment that the guest is exposed to. So it can, so virtual layer can completely control and tune that environment in which the guest will operate. So let us see. So this example is what we talked about. That is, old and legacy softwares that do not match the requirement of the current system can then be run on emulated hardware without the need to change the code. So that means any required environment can be created in the virtual machines with the help of this virtualizing layer, which is a hypervisor. Next feature is isolation. It is an obvious feature of virtualization. Virtualization allows providing guests, whether they are operating system or applications or entities, with a completely separate and independent environment in which they execute. So it allows multiple guests to run the same host without interfering with each other. So basically, what will happen is that if one guest even one virtual machine tries to access the resource of other virtual machines, those instructions will be it will be prevented by hypervisor, because all the applications, all the instructions are going through hypervisor. It provides a separation between host and guest. The virtual machine can filter the activity of the guest and prevent harmful operations against the host. Next feature of virtualization is portability. So portability is another advantage of virtualization, especially for execution virtualization techniques. Portability allows having your own system always with you and ready to use as long as the required virtual machine manager is available. So the concept of portability applies in different ways according to the specific type of virtualization considered. So we look at more into this when we study the types of virtualization, but this is easy to understand that virtual machine instances are normally represented by one or more files that can be easily transported with respect to the physical system. Moreover, these files which are there, they are completely independent. They do not have any dependency with other virtual machine, excepting with that with the hypervisor. So they tend to be self-contained since they do not have any dependency besides the virtual machine manager for their use. There are also some disadvantages of virtualization. It has some downsides. So let us look into that. Um, First is the first is performance degradation. So when we say performance degradation, we are talking in terms of we refer to performance in terms of delay. So since the applications are not running on the native hardware or the local hardware, they are running on the virtual machines. And these virtual machines are exposed to a layer of indirection, that is hypervisor in between. They can experience delay. So Performance is definitely one of the major concerns in using virtualization technology. Since virtualization interposes an abstraction layer between the guest and the host, the guest can experience increased latencies. Then inefficiency and degraded user experience. So virtualization can sometimes lead to an inefficient use of the host, particularly when some specific feature of the host cannot be exposed by abstraction layer, then it becomes inaccessible. So if there is some feature of the host which cannot be abstracted by the hypervisor, that means it cannot be made available to the virtual machine, then that would lead to inefficient use, and it will also indirectly lead to degraded user experience. Security holes and new threats. So since these virtual machines which are there, they are sharing the same physical infrastructure. So security is one of the major concerns for the users, especially those users who are having sensitive data. So virtualization opens the door to a new and unexpected form of phishing. What is phishing? So phishing is a malicious practice aimed at capturing sensitive user information such as usernames and password by recreating an environment that is identical in functionalities and appearance to the one that manages this information. So this is the formal definition of phishing. Let us see. Look at this with the help of an example. So suppose you use a Gmail account wherein you are supposed to enter your username and password on that page. Now, if some malicious user, recreates that page, which looks absolutely identical to the login page of the Gmail, and that pops up whenever you want to log in the Gmail, then you will be feeding your username and ID on that particular page, which will be visible to the malicious user, and then basically they have captured your sensitive information. So this capability of emulating a host in a completely transparent manner led the way to malicious programs that are designed to extract sensitive information from the guest. So let us look at some examples of these kind of programs. First was BluePill. So what did BluePill do? It moves the execution of the installed operating system within the virtual machine. So that means whatever the installed operating system was, it could capture that and move that execution into the virtual machine. Now, whichever virtual machine in which that installed operating system is moved into, that will have the complete control and complete access to other virtual machines also. Next example is subvert. What is subvert? It infects the guest OS, and when the virtual machine is rebooted, it gains the control of the host. Right. So these are the two examples. So security. So if you see in the first feature, we discussed that increased security is a desirable feature which virtualization brings in with itself. But then it is also a threat, and we'll look at this when we study security of cloud computing in later lectures. Okay, let us look at this last concept before we wind up today's lecture. There's a concept of server consolidation, which was made possible due to virtualization. So as we said that virtualization initially came in 1972. It was a concept which was introduced by IBM, but for many years it remained with them and did not become very popular. But then what happened was with the increasing need of computing resources and storage, gave rise to huge servers, or which was these huge aggregation of servers called as data centers now. But these data centers, to ensure that the servers were not underutilized, required a technique which is called as server consolidation. So server consolidation is a technique for aggregating multiple services and applications originally deployed on different servers into one physical server. So there are some services which are deployed in different servers. They all can be aggregated and put on one physical server. So how will this help? This will help in reducing the power consumption of the data center, and it will also help utilize the underutilization problem. So for which virtualization technology is fundamental. So due to virtualization technology, server consolidation became possible. So this is the reference. Thank you.